Okay, so for log to the base 8 of 13 times 7, all right, what rule do we need to use here? The product rule. Because notice we have the log of the product. We can expand that as the sum of their individual logarithms. So log to the base 8 of 13 times 7 will be this, log to the base 8 of the first number, which is 13, and then plus log to the base 8 of the second number, which is 7. Okay? So that's how we expand using the product rule. The log of the product is equal to the sum of the individual logarithms. So log to the base 8 of 13 times 7 will be log to the base 8 of 13 plus log to the base 8 of 7. And I will go no further than that. Are there any questions about problem number 1? All right, number 2. Here we got the natural log, or ln, of e to the 4th divided by 8. Natural log of e to the 4th divided by 8. So what rule do I need to use here? This time the quotient rule, because I have the natural log of the quotient. And I can write that as the difference of the individual logarithms. So ln of e to the 4th divided by 8 would be ln of the numerator, e to the 4th, minus ln of the denominator, which is 8. Okay. And I'm not done yet because I can do something with ln of e to the 4th. And that means I can use one of the properties of natural logarithms, which states if I have the natural log of e to whatever my exponent is equal to that exponent. And that's because ln and e are inverses of each other. So what would ln of e to the 4th be equal to? 4. So I have 4 minus ln of 8. And I will go no further than that. So ln of e to the 4th divided by 8 will simplify as 4 minus ln of 8. Okay. Questions on number 2. All right, number 3. Let's say we got the log to the log of n to the negative 6th power. So for log of n to the negative 6, what rule do I need to use here? The power rule. Because here that exponent of negative 6 tells me I need to use the power rule. And when I do that, I need to bring that exponent in front of the logarithm. So that negative 6 would go in front of the log of n. Now I'll go no further than that. So log of n to the negative 6 would be negative 6 times log of n. Okay. Are there any questions about problem 3? Now problem number 4, here we got log to the base 8 of 64 divided by the square root of x plus 1. Log to the base 8 of 64 divided by the square root of x plus 1. And we need to expand this as far as possible. And I might as well put this in parentheses. So in this case here, what rule do I need to use here first? The quotient rule, because I have a numerator and the denominator. So we'll just expand that using the quotient rule. So log to the base 8 of 64 divided by the square root of x plus 1 would be this. Log to the base 8 of the numerator, that's 64, minus log to the base 8 of the denominator, that's the square root of x plus 1. All right, so let's see if we can simplify this a little bit. Let me bring down log to the base 8 of 64 and rewrite the square root of x plus 1 in its equivalent exponential form. So here I have log to the base 8 of. Now that x plus 1 underneath that radical would be in the parentheses. It is the square root, so the x plus 1 will have to be to the 1/2 power. So the square root of x plus 1 is written as x plus 1, and that quantity is to the 1/2 power. Now let's think about what log to the base 8 of 64 will be. 2. Because you're thinking 8 to what power gives me 64? And it must be 2. So I have 2 minus. Now, what rule can I use here? The power rule, because of that 1/2 is my exponent. That 1/2 goes in front of log to the base 8 of the quantity x plus 1. And that will be as far as I can go with that problem. So log to the base 8 of 64 divided by the square root of x plus 1 will be 2 minus 1/2 log to the base 8 of the quantity x plus 1. Okay. Any questions on problem number 4? Okay. All right, now problem number 5 is this. Here we're going to use the properties of logarithms to condense the logarithmic expression 5 times the natural log of the quantity x minus 9 minus 2 ln of y. And here we're going to write the expression as a single logarithm whose coefficient is 1, and wherever possible, evaluate the logarithmic expression without using a calculator. So here we got 5 times ln of the quantity x minus 9 minus 2 ln of y. And we want to condense this as a single logarithm. So the first thing you need to do here is make those coefficients for our natural logarithm to be 1. So for this term right here, I need to use what? My product. That coefficient needs to be where? Has to be as the exponent, because I have to use a power rule first. Because when you bring that exponent in front of the natural logarithm, to go backwards, you have to make that coefficient the exponent for x minus 9. So we have to use the reverse of the power rule. So that means I'll have ln of x minus 9 quantity square minus, and that 2, I have to make that a coefficient of 1, so that 2 will be the exponent for y. So it'll be ln of y squared. Okay, so my coefficients for my natural logarithms are 1, and I got a minus sign in between, so what rule can be used here? Thank you. Okay, because that 5 would be the exponent for the x minus 9. All right, so what rule can be used here? Has to be the quotient rule, because I have the difference of the natural logarithms. I can condense that by using the log of the quotient. So this will be the log of, or the natural log of, that x minus 9 raised to the 5th will be in the numerator. The y squared goes in the denominator. So 5 times the natural log of the quantity x minus 9 minus 2 ln of y condenses as the natural log of x minus 9, and that quantity is to the 5th power divided by y squared. Okay. Are there any questions about problem number 5? All right, number 6 is to use common logarithms or natural logarithms and a calculator to evaluate log to the base 14 of 87.5 to 4 decimal places. And then use the change of base property, okay, which is what you're using to come up with a decimal approximation for log to the base 14 of 87.5. Okay, so in this case here, so to use the change of base property, you could use either common logarithms or natural logarithms. In this case, I'm using common logarithms here. So here I'm going to write in the numerator the log of this argument right here, 87.5, divided by the log of my base, which is 14. All right, so in this case here, let me get out of this. All right, so here we're going to be pressing the log key on the left side, and then 87.5, close parentheses. Whatever that is going to be divided by the log of 14. So we press the log key, and then 14, close parentheses. And then we hit enter. Now, we need to round this final answer to 4 decimal places. So what would this value be? Okay, 1.6944. Okay. So that would be the approximate value for log to the base 14 of 87.5. All right, are there any questions about problem number 6? Okay, number 7 is an exponential equation where you're going to solve this by expressing each side as a power of the same base and then equating the exponent. So I have 3 to the 2x plus 1 equals 27. Three to the 2x plus 1 is equal to 27. All right, let's see what we got here. We already got the 3 simplified. That 27 is a multiple of 3, so it would probably be best to write 27 with a base of 3. So here you can just pretty much divide 3 into 27. That's going to go 9 times. 3 goes into 9 3 times. 3 goes into itself 1 time. Now, how many factors of 3 do I have here? 3. So I can write 27 as 3 to the 3rd power. So I'll have 3 to the 2x plus 1 is equal to 3 to the 3rd power. Now my bases are the same. I can set this exponent to be equal to that exponent. So I can set 2x plus 1 to be equal to 3. So I have 2x plus 1 is equal to 3. And now to get 2x by itself, I need to subtract 1. So 2x is equal to 2. And then divide both sides by 2. X is equal to 1. So here x equals 1 is the solution to that exponential equation. Okay. Are there any questions about problem number 7? Okay, now I'll put number 8 over here. And here's problem number 8. We're going to solve that exponential equation, 3e to the 5x. And here we're going to express the solution set in terms of natural logarithms, then use a calculator to obtain a decimal approximation correct to 2 decimal places for the solution. Okay, so here we got 3e to the 5x. 3e to the 5x equals 1977. So in this case here, we're going to have to get that exponential expression e to the 5x by itself. It's being multiplied by the 3, so we need to divide both sides by 3. So that means e to the 5x is equal to, what's 1977 divided by 3? 659. So I have e to the 5x is equal to 659. And now I need to take either the natural log on both sides or the common logarithm on both sides. Well, there's no base 10 here, so I can't take the common log on both sides. But for this e, I do know that ln and e are inverses of each other. So let's go ahead and take the natural log on both sides of this equation. Okay. And ln of e to the 5x is what? 5x. Ln and e, again, are inverses of each other. So I can say 5x is equal to ln of 659. And since 5x is equal to 659, to solve for x, I have to divide both sides by 5. So x will be equal to ln 659 divided by 5. Now I'm sure if you recall when you were doing your homework for these types of problems, you were asked to give the exact value. So this ln of 659 divided by 5 represents the exact value. And now they want the approximate value to 2 decimal places in this case for the solution. So here we press ln and then type in 659 and then close the parentheses around 659. Because whatever that's equal to is going to be divided by 5. Now, what would this value be to 2 decimal places? 1.30. Okay. Because the second digit after the decimal point is a 9. To the right of it, to the right of it is 8. And since it's bigger than 5, we increase 29 to 30. So x will be approximately 1.30. Okay. Are there any questions about problem number 8? All right, problems 9 and 10 are logarithmic equations, okay? Those are the ones you're going to solve, and you want to make sure that you reject any value of x that is not going to be in the domain of the original logarithmic equation. Give the exact answer, and then whenever necessary, use a calculator to give a decimal approximation to 2 places, or 2 decimal places for that solution, okay? And these are the ones you have to do the check. So in your exam, I will be looking for not only the answer, but the part where you have to check your proposed solutions, because these are logarithmic equations. Like in number 9, we got the log to the base 2 of the quantity x plus 2 minus log to the base 2 of 7 equals 3. Let's say I want to solve this logarithmic equation. Okay. So the first thing you need to do here is condense each side as a single logarithm. Okay. So on the left side, what rule do I need to use here to condense? Quotient rule, because I have the difference of my individual logarithms, I can condense that as the log of the quotient. So here, this will be log to the base 2 of, that x plus 2 will be in the numerator, and then the 7 will be in the denominator. And that's going to be equal to 3. Okay. Now the next step would be to write this in its equivalent exponential form. I'm going to write that in its equivalent exponential form since I have the log on one side of this equation. So the way we do that is this. The subscript for your log is the 2, that's your base. This 3 will be the exponent for the 2, and then that's going to be equal to the argument x plus 2 divided by 7. So in exponential form, it'll be 2 to the third equals x plus 2 divided by 7. And then we solve this equation for x. Well, let's simplify 2 to the third. What would that be? 8. And I'm going to write that 8 as 8 over 1. You'll see why. And then that's equal to x plus 2 divided by 7. What I'm going to do here is do cross multiplication with the 1 and the x plus 2, and with the 8 and the 7. I'm just doing cross multiplication. So in this case, if I do 1 times that x plus 2, that's x plus 2. Then that's equal to 8 times 7, which is 56. So here I got x plus 2 is equal to 56. And what do I need to do to get x by itself? Subtract 2. So that means x is equal to 54. Now that's my proposed solution here. Okay, now this is where you have to provide the check on this proposed solution. Okay, so here we take the original equation, replace that x with that proposed solution of 54, so I have log to the base 2 of 54 plus 2 minus log to the base 2 of 7 equals to 3. And then 54 plus 2 would be 56, so log to the base 2 of 56 minus log to the base 2 of 7 is equal to 3. And of course I have the difference of the individual logarithms, so that means I need to use, of course, the quotient rule to condense. So it'd be log to the base 2 of 56 divided by 7, and that's equal to 3. 56 divided by 7 is 8. So log to the base 2 of 8 equals 3. Write this in its equivalent exponential form will be 2 to the third equals to 8. And of course 8 does equal to 8, so that checks. So we can conclude that x equals 54 is the solution to that logarithmic equation. Are there any questions about problem number 9? Solving and checking the proposed solutions. Now, problem number 10, we got the log of 5x plus 1 equals the log of the quantity 2x plus 3 plus log of 2. Okay, so first of all, we need to condense each side as a single logarithm. Well, the left side is already a single logarithm, so I have log of 5x plus 1. Now on the right side, what rule do I need to use to condense the right side? The product rule, because I have the sum of the individual logarithms. I can condense that as the log of the product. So here, bring down that log. What I'm going to do is put this 2 in front of the 2x plus 3. That's what I do. 2 times the quantity 2x plus 3. Now, since I have the logarithm on both sides, I can use what they call the one-to-one property. Okay? Notice I have log to the understood base 10 on the left side and log to the understood base 10 on the right side. That means I can set this expression to be equal to that expression. So I can set 5x plus 1 to be equal to 2 times the quantity 2x plus 3. And from here, I can solve this equation for x. So I bring down the 5x plus 1. And if I distribute the 2 over the 2x plus 3, what would I get? 4x plus 6. All right. So now, what do I need to do to get all the x's on one side? Let's subtract 4x. Preferably subtract the use a variable that has the smallest coefficient and move that over to the other side. So 5x minus 4x will give me just x plus 1 is equal to 6. And if x plus 1 equals to 6, what must x have to be equal to? 5. So my proposed solution would be x is equal to 5. Now, of course, we have to check our proposed solution. So now rewrite the original equation. Using the original equation, I'll replace every x in that equation with 5. So here I have the log of 5 times x, which is 5, and then plus 1. That's equal to the log of 2 times x, which is 5, plus 3, and then plus log of 2. Well, let's simplify what's in the parentheses here. What's 5 times 5? And 25 plus 1 is 26. So I have the log of 26. And that's equal to the log of, what's 2 times 5? 10. 10 plus 3 is 13. So I have log of 13 plus log of 2. I bring down log of 26. Condense using the product rule, because I have the sum of their individual logarithms. So this will be log of 13 times 2. And what's 13 times 2? 26. And I will go no further than this, because notice that the left side and the right side are the same. So I can conclude x equals 5 is the solution to that logarithmic equation. Okay. Are there any questions about problem number 10? So keep in mind with those logarithmic equations, you are required to check your proposed solutions. All right, problem number 11. This deals with compound interest. and it's this. How long will it take for an investment of $2,500 to grow to $5,000 if the annual interest rate is 7% and the interest is compounded continuously? Round the answer to one decimal place. So here we got a $2,500 investment. That would be your principal. And we wanted to reach $5,000. So that's what A is going to be. Your annual interest rate is 7%. Now, what's 7% as a decimal? 0.07. Okay. And it's compounded continuously. So that means we have to use this formula that has the natural base e in it. A is equal to P times e to the RT. A is equal to P times e to the RT. And then just substitute. Our A, which is 5,000, that's equal to P, that's 2,500, times e to the R, that R is 0.07, times T. T is what we're trying to find here. So here's our exponential equation that we have. And then the next step would be to get that e to the 0.07t by itself. We're multiplying it by 2,500, so that means we need to divide both sides by 2,500. So on the right side, we're going to have e to the 0.07t, and then what's 5,000 divided by 2,500? 2. So here we got 2 equals e to the 0.07t. Let me make this t look like a t. Okay. Now, since we have an exponential equation, we have the natural base e, and ln and e are inverses of each other. Let's take the natural log on both sides. So on this side, what's ln of e to the 0.07t? 0.07t, and that's equal to ln of 2. And then to get t by itself, I need to divide both sides by 0.07. And I'll go ahead and do this in the calculator that t is equal to, and of course that ln of 2 divided by 0.07, that's the exact value. But of course we want the decimal value for that, so it'll be ln of 2, close parentheses, and then divide that by 0.07. Now we're going to round to one decimal place. So what would the value of t be? 9.9. And keep in mind, the time in this case is in years. So to answer the question, it would take approximately 9.9 years for a $2,500 investment to reach $5,000 at 7% compounded continuously. Are there any questions about problem number 11? Okay, problem number 12 is solving the system of equations using any method of your choice. It could be either substitution or the addition method. So we're pretty much into chapter 5 in this case. So here we got 3x minus 2y equal negative 5, and then 4x plus y is equal to 8. Now, which method do you think would be best to use? addition. Okay? Let's see if we can add these two equations together. Now, which variable would you think would be best to eliminate, the x or the y? The y, because I got a minus 2y and I got a plus y. But notice I want that plus y to be a plus 2y. So what do I need to multiply that second equation by? By 2. So that means I'm going to have, I'll bring over the 3x minus 2y is equal to negative 5. But that second equation, if I do 2 times 4x, I'm going to get 8x. And then 2 times a plus y would be plus 2y. And then that's equal to 2 times 8, which is 16. Now we can add these two equations together. So here, 3x plus 8x is 11x. And then that's equal to, I already know what the minus 2y and the plus 2y is going to do. Add to 0. They're gone. So negative 5 plus 16 is 11. So I have 11x is equal to 11. So what must x have to be equal to here? 1. So I have x is equal to 1. Now we need to find out what y is. Because our system of equations, its solution would be an ordered pair. We have x, we need to find out what y is. We could use either the first or the second equation to find out what y is. Let's use the second equation. 4x plus y is equal to 8. Replace the x with the 1. So it'll be 4 times 1 plus y is equal to 8. 4 times 1, that's 4, plus y is equal to 8. And what must x have to be equal to here? What must y be equal to? 4. Okay, so y is 4, and we have x equals 1. So our ordered pair solution for this system of equations will be 1, 4. And if you have the time, you can do the check, either mentally or on your calculator if you like, to see if the left side does give you the right side, after substituting the x with the 1 and the 4. All right, questions on problem number 12. Okay, problem number 13 is a system of equations in 3 variables. And we got 3 equations. X minus y plus 3z is equal to 8. 3x plus y minus 2z equals negative 2. And then 2x plus 4y plus z equals 0. And here we want to solve this system of equations in 3 variables. Okay, so the first thing I'm going to do here is label each one of these equations. That first equation, I'll label that as equation 1. Second equation will be equation 2. The last one will be equation 3. And I'll have to reduce these by picking up 2 pairs of equations, reduce each pair as a system as equations in 2 variables. Let's see here. What 2 equations I can start off with? 1 and 2. Okay, so I'll do this over here. First equation, x minus y plus 3z is equal to 8. And the second equation, 3x plus y minus 2z is equal to negative 2. Now, what variable can be eliminated? The y, because I've already got the minus y and the plus y. So I can go ahead and add those 2 equations together. That 1x plus 3x will give me 4x. And then minus y and the plus y add to 0. 3z minus 2z will give me just z, or plus z, I should say, equals 8 minus 2 is be 6. Now that equation 4x plus z equal to 6, this will be equation 4. Next, I need to pick another pair of equations and eliminate the y. So which two equations do you want to use? 1 and 3. Okay. In fact, that's what I chose. X minus y plus 3z is equal to 8. That's the first equation. Equation 3 is 2x plus 4y plus z equal to 0. Now, I need to eliminate the y, since in the first and second equations I eliminated the y. I have to do the same thing here. But if I want that minus y to be minus 4y, what do I need to multiply that equation by? By 4. Guess I use green this time. Times 4. And when I do that, for the first equation, 4 times x will be 4x. 4 times the minus 4y would be minus 4y, plus 4 times the 3z will be 12z, equals 4 times 8, that's 32. And I'll bring over the 2x plus 4y plus z is equal to 0. Now we're ready to add these two equations together. 4x and 2x will give me 6x. Minus 4y and the plus 4y add to 0, so we can eliminate that. 12z plus z is 13z, and 32 plus 0 is 32, excuse me. So here we got 6x plus 13z is equal to 32. This will be equation 5. Now equations 4 and 5 are in two variables. So we'll use those to eliminate either the x or the z. So here's equation 4. That's 4x plus z equal to 6. Equation 5 is 6x plus 13z is equal to 32. Now, which variable would you like to eliminate, the x or the z? Let's eliminate the z. And if I want this z to have opposite signs and with the same coefficient, I need to multiply it by what? Negative 13. Because both of these are plus. One of them has to be negative, and the other one has to be a plus in order for me to eliminate. So we'll multiply equation 4 by negative 13. And when I do that, negative 13 times 4, that's negative 52x. Negative 13 times the plus z will be a minus 13z, equals negative 13 times 6 will be negative 78. Now bring over equation 5. 6x plus 13z is equal to 32. All right, so if I add those two equations together, what's 52x plus 6x? I mean negative 52x plus 6x. Negative 46x. The 13z's are eliminated, and that's equal to negative 78 plus 32. Negative 46. Well, we got negative 46x, that's equal to negative 46. That means x has to be equal to what? 1. So now we know what x is. Okay, now let's use either equations 4 or 5 since they're in two variables, and I already know what x is. We can find out what z is going to be equal to. So, now write this over to the side. Using equation 4. You could use equation 5 if you wanted to. which was 4x plus z is equal to 6. And x is 1, so it'll be 4 times x, which is 1, plus z is equal to 6. 4 times 1 will be 4. And if 4 plus z is equal to 6, z has to be equal to what? 2. So we have x equals 1, we have z is equal to 2. Now we need to use one of the 3 original equations that we started off with to find out what y is. Okay. Let's use equation 2. Because in equation 1, it has that minus sign in front of the y. So using equation 2, which is 3x plus y minus 2z equal negative 2. Here, x is going to be equal to 1. So it'll be 3 times 1 plus y minus 2 times z, which is 2, equals negative 2. Here, 3 times 1 would be 3, plus y, and then minus 2 times 2 would be minus 4, equals negative 2. And then, let's do this. What's 3 minus 4? Negative 1, so it'll be y minus 1 equal negative 2. Then get the y by itself, we'll just add 1 to both sides. Y has to be equal to what? Negative 1. Okay, so that means our ordered triple solution for this system of equations in 3 variables will be, well, the x comes first as 1, then the y, negative 1, then z, 2. So 1, negative 1, 2 is the solution, or the ordered pair solution for this system of linear equations in 3 variables. Are there any questions about problem number 13? Okay, problem number 14 is a system of nonlinear equations. And this is in 2 variables, by the way. So here we've got 2x plus y equals negative 5. The other one, y is equal to x squared plus 6x plus 7. And I want to solve this system of equations. And it does say use the substitution method. So on this one, you must use that substitution method in order to solve that equation. So here I got 2x plus y is equal to negative 5. Now I've already got an equation to solve for y. Y equals x squared plus 6x plus 7. So I can go ahead and use that substitution method. So since y is equal to this x squared plus 6x plus 7, I'll take that and substitute it for this y in the first equation. So in this case here, I bring down the 2x plus this y would be replaced with that x squared plus 6x plus 7 equals negative 5. And now let's combine some like terms. And I'm also going to put this in descending powers on the left-hand side. I'm going to put the x squared first. What's 2x plus 6x? 8x. So I got x squared plus 8x plus 7 equals negative 5. Now I have a quadratic equation. That means I need to put a 0. I have to have a 0 on one side of this equation. So let's move the minus 5 over to where that plus 7 is. Or move the negative 5 over by adding 5 to both sides. I get a 0 here, but on the left side I have x squared plus 8x plus 7 plus 5 is 12. So x squared plus 8x plus 12 is equal to 0. Now let's see if we can factor that quadratic expression into two binomials here. So here x squared would be x and x. What factors of 12 give me 8x as a middle term? 6 and 2. And they both have to be plus. So I have x plus 6 times x plus 2 equal to 0. Now we solve, well, set each binomial factor equal to 0. So I have x plus 6 equal to 0, x plus 2 equal to 0. Well, for x plus 6 equal to 0, if I subtract 6, you'll get x is equal to negative 6. And then for the x plus 2 is equal to 0, we have x equal negative 2. So here x equal negative 6 and x equal negative 2, those are my two x values here. And for each one of those, I have to find out what y is. Well, I know what y is. I have y equal to the x squared plus 6x plus 7. So let's use that to help us find out the values for y for each of these x values here. Let's start with x equal negative 6. And then we're going to substitute every x in that equation with negative 6. So here in this case, negative 6 and u squared, that's negative 6 times negative 6, which is 36. Plus 6 times a minus 6 will be minus 36. And then bring down the plus 7. Now in this case here, 36 minus 36 gives me 0. And 0 plus 7 is 7. So one ordered pair that satisfies this system of nonlinear equations will be negative 6, 7. Now for x equals negative 2. And really, it doesn't matter which one of these two equations that you use. Okay? Doesn't matter. So here y is equal to, and I'm replacing the x with negative 2. That'll be squared plus 6 times negative 2 plus 7. Square negative 2, you're going to get 4. 6 times that negative 2 would be minus 12 plus 7. And what's 4 minus 12 plus 7? Negative 1. So my other ordered pair would be x is negative 2 and y is negative 1. So these two right here are the ordered pairs that satisfy this nonlinear system of equations. Okay. Are there any questions about problem number 14? Okay. And problem number 15. Here we're going to use the addition method. So here you got x squared minus 4y squared equal negative 7. And then the second equation is 3x squared plus y squared equals 31. And this one you do need to use the addition method because both the x and the y are squared. Now which variable do you want to eliminate, x squared or y squared? Let's use the y squared. I say that because notice I have a minus sign and a plus sign here. And I got 4y squared, so if I want that plus y squared to be 4y squared, I need to multiply it by what? By 4. So now when I do that, the first equation, I'll just go ahead and bring that over. X squared minus 4y squared is equal to negative 7. The second equation, 4 times that 3x squared would be 12x squared, plus 4 times the y squared would be 4y squared, and then 4 times 31 would be 124. All right, so let's add these two equations together. 1x squared and 13x squared would be, I gave it away. 1x squared and 12x squared, that's 13x squared. And then minus 4y squared and the y squared are gone. Negative 7 plus 124 would be 117. So I have 13x squared is equal to 117. Divide both sides by 13, I have x squared is equal to 9. And the opposite of squaring something would be to take the square root, and what do I need to include? Plus or minus. So here x is equal to plus or minus, the square root of 9 is 3. So I know I have x equals plus or minus 3. That means x is equal to positive 3, x equal negative 3. And then we need to find out what y is for each of those x values here. Let's start with x is equal to 3. And I can use either one of these two equations here. Let's see, I'll use that first equation, x squared minus 4y squared equal negative 7. And then replace that x with the 3, so it'll be 3 squared minus 4y squared equal negative 7. And what's 3 squared going to be equal to? 9 minus 4y squared equal negative 7. And to get that negative 4y squared by itself, I need to do what? Subtract 9. So that means negative 4y squared is equal to what's negative 7 minus 9? Negative 16. So I got negative 4y squared is equal to negative 16. Divide both sides by negative 4. That means y squared is equal to 4. And then take the square root on both sides and include the plus or minus symbol. That means y is equal to plus or minus 2. So that means for x equals 3, my y values will be positive 2 and negative 2. So I have two ordered pairs for the x coordinate of 3. Now for x equal negative 3, and I'm still going to use the x squared minus 4y squared equals negative 7. Well, x is negative 3, so it'll be negative 3 squared minus 4y squared is equal to negative 7. Well, what's negative 3 squared? 9. So I have 9 minus 4y squared is equal to negative 7. And you know what? I can stop right here because notice I got the same thing here when I replace the x with 3. And I'm going to end up getting plus or minus 2 when I solve for y. So, for negative 3, my y values are going to be positive 2 and negative 2. So these are all the ordered pairs that satisfy this nonlinear system of equations. 3, 2, 3, negative 2, negative 3, 2, and negative 3, negative 2. Are there any questions about problem number 15? Or does anybody have any questions about what will be on exam number 4.